Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So somebody sent me an email and asked me about this method that I've been using to do both division and multiplication and had several questions over it. So what I'm going to do in this video is I'm going to cover some of those questions and show you why I do the things that I do. Now, if we look at Book 5 and Proposition 12, it's about similar triangles, actually, even though it doesn't look like that at all, actually. It's about similar triangles and proportional sides. So you can do both division and multiplication because multiplication is derived from division. So let's see how I solve this problem, how I solve both division and multiplication problems using only addition, okay? Only addition. All right, let's see how I do it. So in this case here, what I say is let's get the bottom part of this, which is 3/4 over 3/2, okay? So let's get this bottom part here to be a fraction which is a multiple of 1, okay? And how do we do that? Well, if we say 3/2 plus 3/2, that's the same as 6/2. And of course, we know if we have 6/2 that 2 measures 6 exactly, okay? In other words, if you have 6, it fits, 2 fits into 6. 1, 2, 3, okay? So, but what we do to the bottom part, we also have to do to the top part, which is 3/4 plus 3/4, okay? Now, you can think of this in terms of similar triangles. If you have any angle like this, and you say this here is 3/4, and this here is 3/2, and you can add this. If you decide to increase the side here by another 3/4, then again, the side here will be in proportion. And so you can increase and decrease as you like, right? Okay, so stop the video and think about that if you need to. Now, let's just clear the screen up a bit. This here gives you, what does it give you? 6/4, like that, yeah? And at the bottom, you're going to have 6/2. Just leave the 6/4 alone. And on the bottom, you're going to have 2 measures 6 3 times, right? Okay. So now you've still got this little guy here, and you can say, okay, well, if I add 6/4 to 6/4, I'm going to get 12/4, but I'm going to do the same thing to the bottom, 3 plus 3. So I just reapply this proposition here, okay? I can reapply it as many times as I like. And so I come back here again, and that becomes 12/4 over 6, right? Make sense? And then, of course, 4 measures 12 exactly. Measures 12 as 3/6, right? And now, if I really wanted to, I could find a common factor between these two. And it turns out that that's a half. And you can do that even without numbers, as I've shown you in previous videos. So the final result is that 3/4 divided by 3/2 is equal to a half, okay? So as you can see, all I've done is I've used only addition, okay? Addition and a very simple knowledge of the fact that if one measure or one number measures another exactly, I can simplify it, right? As I did over here, and again as I did here, okay? Because 2 measures 6 and 4 measures 12. Now, multiplication is just the, so let's just get rid of that and I'll show you. Multiplication is just the reciprocal division measure. Okay, so for example, if you said, let's take this example. If you said let's get rid of that too. And let's say times 2/3. Okay. That is the same as saying 3/4 divided by 3/2 and 2/3 divided by 4/3. Okay? It's the same. So both of these are division problems. And since you know how to do division already, you know how to do the multiplication. And all you need to know is how to do addition. Okay? And a simple fact about one number measuring another number as a unit. So basically, if we say 12 divided by 4, what that means is we don't have four groups like this and we equally distribute. That's a stupid concept. It's very difficult to do this, especially if you have fractions. Imagine if you had something like 12 over 12 over 5 divided by 7 over 19. Imagine breaking 719 into equal groups, okay? So what are you going to have? 7 groups of 1 over 19 and then distribute that? Can you see how difficult that is? So this set theory model is very, very difficult for kids to understand. They never learn it and they never understand it. Okay, they just simply learn how to use the method. So when you look at this division here, what the factoring idea is that you have 12, okay, like that. And then you use 4 as a measuring unit. 1, 2, and 3, right? So that's what this means. 12 divided by 4 means the measure of 12 using 4 as a unit. So when I do things like 3 plus 3 over 2 plus 2, what I want to do is I want to get it into a form where the bottom one fits into the top one exactly. Okay. And it's very easy to know that since I'm using the most primitive concept of measure. Okay. And division, by the way, is measure. So look, I'm writing a new book right now and it's going to cost. I'm not giving it away free. But if you go to my academia site, you can learn a lot more than you've ever learned by reading my free ebook called Learning the Correct Way. If you're not already a subscriber, hit that subscribe button now. Don't wait. Click like, tell your friends about it, and follow me on academia.edu. I'm John Gabriel. Till